Before we move on to finding the solution of a quadratic equation, let's quickly review how quadratic polynomials first factorize. The general form of a quadratic polynomial is ax squared plus bx plus c. Here is the first quadratic polynomial. Here a will equate 1, b will equate 7, and c will equal 12. One of the ways in which we factorize two polynomials was by splitting the middle terms. The technique was easy. We first write the coefficient of the middle terms as the sum of two numbers n1 and n2, and the two numbers are such that their products equal the product of a and c. So can we think of two numbers such that n1 plus n2 is 7 and n1 times n2 is equal to 12? Yes, 3 and 4. If we 3 plus 4 is 7 and 3 times 4 is 12, so the polynomial can be written like this. The middle terms after expansion will look something like this. What we have done here is split the middle terms. 7x was written as 3x plus 4x, and how does this help after expansion? We group the terms like this, and how does grouping help? We look for common terms in each group. In the first group, x is common, and in the second, 4 is common. So this can be written as x times x plus 3 plus 4 times x plus 3. Now in this polynomial, x plus 3 is common to both terms. Taking these common factors out from both terms, we get this. So this quadratic polynomial was factorized today. The two factors of this polynomials are x plus 3 and x plus 4. If you understood this concept of factorizing polynomial, then finding the roots of quadratic equations is very easy. Now assume that the quadratic equation we have x is equal plus 7x plus 12 equals 0. We need to find it through by roots. We mean the value or the values of x which satisfies this equation. To find the solution or the roots, all we need to do is factorize the polynomials on the left. As we have already seen how it's factorized, we can write this as x plus 3 times x plus 4 equals 0. Now I want you to think if it logically when the product of a and b is equal to 0 and can be implied, we can say that at least one of them will be 0. Either a or b will be 0. If we apply the same concept to disk, we can say that either x plus 3 equals 0 or x plus 4 equals 0. Transposing the constants to the right, we can say that x equals negative 3 or x equals negative 4. These are the roots of this quadratic equation. If you substitute any of these values in this equation, you will see the equation is satisfied if things have instead to negative 3. In place of x, we get a 0, and it is the same with negative 4. These two other roots of this quadratic equations. Now, why don't you try finding the roots of the quadratic equations? You should get the roots SQ and negative 3. So, the method